morning, everyone. Let's start the last day of lectures here in the NIPEWeek. Now we have the international section. And before we start, I just have to give some information for the Brazilian participants. So I will do this in Portuguese. Para amanhã, as visitas técnicas, quem tiver interesse, manda um e-mail para o jprates@unicamp.br para fazer a confirmação, porque a gente vai realizar a visita havendo um quórum mínimo para a gente fazer isso, tá bom? Obrigada. Okay, let's start. I would like to thank you, the speakers outside Brazil. Thank you very much for accepting the invitation. And I will start with the Professor James Bo, Holm-Nielsen. I'm sorry, here we have an A, extra A. It wouldn't be here. And Professor James will talk about biomass, biorefinery, and bioeconomy. Thanks for being here with us. And the floor is yours.
Yes. Can everybody see this one?
Yeah, we can see.
Okay, thank you, Bruna, and all the rest of the team. I'm delighted to make a short presentation. I'll show you all too much, so I have to speak fast. But I'm very delighted to be joined with you in this NIPEWeek in your Center for Energy Planning. I'll talk a little bit, very short, brief on wind, solar, but of course mainly focusing on bioenergy, biorefineries, what we can obtain jointly. And of course, in our department at Energy, we are 350 persons at Aalborg University, and we are focusing very much on the box number 7 and 13, but it's really have a lot of impact to all the other into this 17 SDG goals. And of course, we are also all of us aware that we are decades behind time schedule to make big changes from this dramatic increase in temperature. But we have good options. And one of the base loads for the future is, of course, bioenergy, but also wind and solar and energy efficiency, energy saving. We have to skip the fossil fuels, not year 2000, 2100, 2050, but as fast as possible. And some of the good messages, it's from UNEP and Bloomberg, what is really going on in the developing world, the rapid increase in wind and solar, and much more to go. And if we look upon the European, you also had one of my highlights, it's a donut economy, a circular economy, and it's very much also in the way we're thinking about all the developments in the European terminology. The European Green Deal also dealing with all this. And if I just show you very briefly what we have gained in Denmark, we have now 37% of the entire energy utilization is from renewable energy, and we can reach between 66 and 100% before 2040. How? Yeah, you won't believe it, but there's happening a lot also in my country with PV solar and passive solar. So a lot of things are installed the peninsula of Denmark, just north of Germany, because of the technology-driven changes that the price per kilowatt installed is driving down to very, very low prices. Just is this curve from PV solar. Then I'm from the country where we love wind energy, and the more greenish and reddish yellow, the more windy we have it on the west coast of Denmark. And we have created since Paul 100 years ago the theoretical background. So the window or tapping the energy from the wind is of course mainly due to the wind speed. And there we are driving ourselves and hopefully jointly with Western European countries, but all over the world, offshore wind. And it's one of the companies installing offshore wind. I think it's one of the leading ones. And what is really interesting, you can see here onshore, offshore wind in euro per megawatt installed cost, and the cost for offshore wind have been driving down 63% in 5 years. So nowadays, offshore wind, onshore wind, PV solar are lesser in cost of the full-scale plants than natural gas, coal, and nuclear. Good message. And in our ocean, in the North Sea, but also the German, the UK, the Netherlands ocean, part of the ocean of the North Sea, a lot of things are going to happen in the coming years. It's from my hometown. We are shipping out very many projects to the North Sea, and these hubs are not only theoretical, they are right now on the planning artificial energy islands. Huge influx of green electricity to the mainland of Europe, but also to UK. Now I shift to biorefinery because all this we have to see in the scope of integration. We have all knowledge of our biology, natural vegetation, croplands, pasture rangelands. What can we use all our beautiful countryside from? Croplands, green energy, pasture lands, also green energy, rainforest and natural forest is of course no go. So in my country, it's our natural forest. We cannot go for this, but we can go for agricultural part of the land in very sensitive planning. And these two platforms we have been attacking and fulfilling the last 2-3 decades. Instead of petroleum raw oil, we have the biomass. So we are really like deeply to work into biorefineries. And the same platform over here, sugar platform, biochemical or thermochemical, we are working in both platforms for combined heat and power, fuels, chemicals, and materials. It's where we want to cooperate with you. And my own donut economy is here. You can see we have the photosynthesis. We have a lot of platforms of feedstocks for AD. So one of the circular part is the anaerobic digestion, recirculation of biofertilizer, but over here it's energy utilization from the biogas plants. And to show you that this platform is one we really love is that we have a lot of installations in Denmark, and I can tell you we are speeding up due to this tragic war in Ukraine, the Russian aggression. We are speeding up, tripling the speed of installing natural biogas. So in the next 5 to 7 years, we will have full green gas in our natural gas grid in Denmark, meaning that it was a picture of 2011. We already have fulfilled these yellow dots for upgrading biogas to biomethane to the national gas grid, but we are speeding up even further. So before 2030, we have full change of fossil gas to green gas. It shows from the national statistics, we already at 25% green gas, but it will be speeded up due to a lot of more projects in the pipeline. It's where I want to give my part into our cooperation for the future, because the biogas can be used for the transportation in Sao Paulo region or greater Sao Paulo. We can also use it for industrial utilization, so we can save a lot of CO2 replacing coal and oil with green gas. Like here, it's 2 industries producing insulation material. And then we have been working with this, and it's really where it's getting highly interesting for us in the future to produce from a lot of material in the biotech platform, the fermentation platform. We can produce a lot of amino acids of high quality, a lot of other products, organic acids, and biochemicals of any kinds. This one is already an existing plant in our area producing these amino acids, lysine, and other replacements for soybean and so forth. And I show you just this picture here because I really like to cooperate with our Brazilian colleagues. So from the cane industry, we have the bagasse, and we specifically also the bagasse is, to my understanding, as good as if you do some pre-treatment also for the AD. It's a concept I really want to challenge you on, because you're going to see first, second generation bioethanol in the sugar industry, bagasse for combined heat and power. But this platform we really want to fulfill and also use all the produced gas, the green gas, because it has a fantastic way to be used in the future, not only the methane, but also the CO2 and a lot of products with the biofertilizers and so forth. We are highlighting, it's why I showed you the offshore wind and the onshore wind and solar, which will be big time growth factor in Europe. So when we have surplus cheap electricity, we can electrolyze it for hydrogen, combine it with nitrogen from the air or the CO2 from biogas plants, and then we can use it for hydrogen or ammoniac or methanol. And we are targeting quite much in different projects, also methanol, where we're combining H2 and CO2. So it's a fantastic challenge for all of us to make big changes and shift as fast as possible away from the fossil agenda into a green way of sustainable living for the future. So it's my part of going into all this. So thank you for listening.
Thank you very much, Professor Hens. So the questions will be done after all the presentations, right? So we have the audience has doubts, we can do this in the round table. Now I will announce the second presenter is Professor Jean François Mercure. He's senior lecturer in global systems at University of Exeter. To talk about the new economics of innovation and transition, evaluating opportunities and risks. Thank you very much, Professor Jean, and the floor is yours.
Okay, thank you. Just a moment. I realize it's asking me first. Okay, let me check whether it works.
If there is a message that you're not allowed to share your screen,
Yeah, that's good.
I ask you to leave the meeting and rejoin us, because this has been working during the presentations. This is a technical problem of Google Meet. So you can leave the meeting and join again.
Sorry for that.
No problem.
Should work now.
Okay, now we can see.
Okay, wonderful. Okay. Okay, thanks very much, everybody. Thanks for your inviting me and being part of this. Very happy to be a part of the event. So,
Excuse me, can you put the presentation mode? Cannot see
yes,
the
yes.
presentation mode.
Is this better?
No, I think you have to share the all the screen, not a window, because you cannot see the presentation mode when you share a window. So you have to share all the screen.
Okay, let's try again. What I'm gonna do is my entire screen. Okay. What about now?
Okay, it's perfect. Thank you.
Okay, great. Okay, thank you. Okay, I'm going to introduce this project that's called Economics of Energy Innovation and System Transition, and I'll talk about risk opportunity analysis. That is a sort of method of decision making we've designed in this project that I will call EAST for simplicity, Economics of Energy Innovation and System Transition, and give an example with road transport analysis. Okay, so we, a number of partners in the UK, in Brazil, in India, China, we have developed this project funded by the UK government, that is the Department for Business, Energy and Industrial Strategy, in cooperation with the Children's Investment Fund Foundation. And it's about, we call it deciding how best to decide, which is which kinds of analyses and information we use to inform climate policy in different domains. So we, there for funding this project, the problem was thought by UK governments and other partners that decision-making for planning this long-term transition we're looking at for low carbon and avoiding climate change is often made using too simplistic evidence and models. And we think there's cutting-edge science analysis in the evolutionary research area that is useful to provide new and better insights for this. We do this analysis with a focus on China, India, and Brazil, and it's partly at the request of UK government and partly out of interest to sort of cooperate. And we were also part of the COP26 climate summit on that. This is the list of institutions that are part of this. So Unicampi is one of our partners, notably, but there's a number of partners all over the world. So what's the question? So we think that the way governments decide on how to go ahead with a transition is maybe not the most practical approach. So what's been happening, and I'll give an example from the UK, and then we can think of how this reflects in other countries, but just for the sake of simplicity, in the UK government, we use what's called the Green Book, which is essentially guidance for doing cost-benefit analysis on projects. And cost-benefit analysis has got this sort of feature that it's looking at a system the way it is now, very static, and then see what change we apply to it and what the cost and benefits would be to that. But it doesn't have a very good understanding of the dynamics of a transformation that really is the deeper thing that's happening underneath. And so it misses a lot of important things. But nevertheless, the recognition has been made by UK government on that in the Treasury, looking at what is transformational change. And obviously, the low carbon transition is transformational. And so here's the definition that has been added to the Green Book. But it doesn't change the fact that there isn't a clear methodology. And obviously, the low carbon transition is transformational in that systems change irreversibly, that is social, economic, and technological systems, especially the energy system, for example, and technologies and resources will co-evolve and change over time. And we see, for example, solar energy going down in costs really rapidly in electric vehicles. And I'll show some data over that. And we also create new capabilities, and often the cost-benefit analysis doesn't really see that, doesn't really understand the creation of resources in the economy. And of course, uncertainty is very, very important, very large. So we could argue government policy analysis is the method is only designed for assessing marginal change, not transformational change. So we published this kind of theoretical framework, if you like, to explain what we think could be replacing a cost-benefit analysis and taking better decisions, and how that could work in a very evolutionary approach, where we understand that everything changes in the economy, in technology, and this is the result here. And I'll just outline this briefly. Okay, so imagine you want to decarbonize transport, and it's already a fairly complex problem in its own sake, but you could have, for example, some subsidies for electric vehicles or the flex fuel system, or you could have EV mandates in the system that forces manufacturers to produce more electric vehicles. But of course, it has deeper implications. It's not decarbonizing transport is not just about transport. It's about, for example, the oil sector, what's happening there, and there could be some industrial decline in areas that have been involved in oil, and there could be also potential stranded assets where there used to be wealth, and that then the values is less usable. But of course, there's new manufacturing, new jobs, so new sectors which may or may not be in the same geographical locations. But most importantly, and what's often forgotten, is that those technologies and the innovation underneath begins to influence other areas, other sectors, and this then begins to change productivity across the economy as we change the usefulness or the cost of various technologies with the sort of cumulative innovation that's happening everywhere. And of course, transitioning towards low carbon does foster innovation. So you could say something like, it would be more effective to steer the whole transition, recognizing that there are substantial uncertainties, rather they try to identify what the endpoint destination is or the pathway, which would be inevitably with some false certainty. So a degree of certainty we think we have that we don't really have. So here's kind of the proposal is to look at cost and benefits in sort of probabilistic terms, where we're thinking of there's the most likely outcome of a policy that we can analyze in our cost benefit analysis, but there's also what could be the risks, and call it tail risks. And there's the sort of most likely benefits, and then there's the tail benefits or the tail opportunity. And all of that can be looked at by different sort of stakeholders within governments. So let me just give an example, and that must include the sort of dynamics of transformation that are very uncertain. So for example, we used to think that we would have, say, a pricing policy will change the quantity of, say, emissions or energy use to a new equilibrium, and then we would say that the probability is sort of, the uncertainty is parametric, so we know where the outcome lies, but we're kind of lying to ourselves thinking that we know this. In reality, it's dynamical. So we have let's say, a pricing policy, but it changes the direction of evolution of the technology system and the innovation system, and then we have a range of possible outcomes instead of a well-known outcome. Okay, so I'll talk about road transport sort of very briefly, not wanting to be over time. We know that any innovation develops according to this diagram where we've got early adopters and early majority, late majority. And we sort of know, and that's kind of well established in the sort of empirical literature, that early adopters make a demonstration effect to the early majority, who make a demonstration effect to the late majority. So the early majority doesn't happen until the early adopters have sort of demonstrated. But there's also the fact that the costs and prices of technologies are changing according to how many adopters there are in this. And of course, when we get to the late majority, often there's less cost reductions. But when we have the early adopters, it's changing really rapidly. And think of solar energy and wind power at the moment. It's radically transformed and changing really quickly, including in Brazil, say. So what does that mean? So talk about electric vehicles. And of course, in Brazil, there's a flex fuel system and not many electric vehicles. And it's kind of a question how that's developing. But in other countries, it's changing really quickly. You look at China, US, the EU, and say the UK, especially China, electric vehicles are taking off at a super rapid rate. And that's causing costs to go down super rapidly because the batteries are coming down in cost, and the cumulative amount of innovation that is happening there is really transforming the system. Now, electric vehicles could rapidly become cost competitive with conventional vehicles, where after which point people begin to save money out of buying electric vehicles. So you can imagine a broad transformation on the horizon. And this is happening super fast, to the extent that you can make predictions over where the costs would go just following effectively this data here, the rate of cost reduction, and see how things are going if the takeoff of electric vehicles carry on the way it's been going. And here I'm showing in solid lines is the price of the cars, and in dotted lines is the ownership cost. That is, you can see the ownership cost. There's a lot of it that's the fuel for conventional vehicles, which are the black lines, and the electric vehicles are the colored lines. And I've used 3 different learning rates just to have an uncertainty bound, and you see where things can go. You could say that by 2030, electric vehicles are cheaper on the ownership cost level in almost every country. But Brazil, not so much, because the sort of policies aren't in place really to facilitate that, but they could be. And then we can easily project what happens to the whole fleets of vehicles over time with different levels of policies. And we find that it's not quite so much taxes and subsidies that really work. I mean, here I'm adding taxes, and then I'm adding on top of that regulations. And then I'm adding on top of that the EV mandates. The EV mandate is forcing manufacturers to produce a certain number of electric vehicles. And we just find that although the taxes and subsidies, they do help a bit really, and the regulation helps reduce emissions of the conventional vehicles, but the EV mandate really accelerates everything, because it's really accelerating the rate at which the early adopters are buying into the system, such that the early majority can come in more quickly into the markets. So this is like the way we could see how policy can really influence the direction of change. And of course, this is very uncertain, so we can't be sure these projections are correct. And so we have to see the direction of change rather than sort of what the endpoint is, and say, are we going in the right direction? How do we influence the evolution of policy? So yeah, as a conclusion, so what's important is the feedback. So you look at the diffusion rates and the costs, and they mutually reinforce. Where the costs go down, there's more diffusion, there's more costs going down, and there's spillovers to other sectors, and it creates new businesses and new people come into this. So, and meanwhile, the reductions in fossil fuel use affects employment in high carbon sectors that needs to be addressed. The likely impacts are that combining the policies is very effective to transform the system quickly. And the risks, well, the pace of decarbonization could actually really go fast, and that could cause problems in the economy. And there could be new inequalities that arise as a result of reorganization of employment. So that also needs to be understood, how we design the policy. And the opportunities, well, the costs are declining, and we could actually be creating brand new industries that employ a lot of people. So I think in the risk opportunity analysis, these are the steps that really should come in and really sort of be understood in order to well inform and effectively inform public policy. So that's it. That's what I wanted to say, and I'll be happy to take questions. Thank you very much.
Thanks, Jen. Questions will be done in the round table. Let's go to the next presentation. Please, I invite the Peter Flippo, who's the Business Development Manager of Bioprocess Pilot Facility at the Biotech Campus Delft, to talk about the BPF, the Bioprocess Pilot Facility. Thank you very much, Peter. The floor is yours.
All right, thanks. You can see my screen yet?
Not yet.
Okay. And something is not here. Yeah.
If there is any problem about permission, you can leave the meeting and join again. So the problem can be solved.
All right. All right. So thanks for having me here. I'm going to share some details about unlocking the potential of the biomass. So what's the catch here? What's the challenge? How can we help you out with unlocking the value of the biomass? And so we are the BPF. We are the Bioprocess Pilot Facility, a pilot plant based in Delft, the Netherlands. And we take typically projects of our clients, and we are a service provider. We help them to scale up processes and make them ready for commercial scale production. So first, pretreatment technology is basically the foundation of a successful biorefinery. To unlock the promise of the lignocellulose, it's already a promise for decades, how to get sugars and lignin out of lignocellulose. There's abundant of feedstock available. Lots of research is being done at lab scale. However, only a few commercial plants exist. And why is that? Well, there are a couple of reasons for that. Techno-economic reasons has to do with the oil price, sugar price, or the sugar quality. Also feedstock availability, the logistics around that, and consistency of the feedstock. So that's the techno-economic reasons for having few commercial plants. And secondly, also there are scale-up challenges. There are not really pilots existing to validate the pilot technology for the market, because pilot plant costs can typically go easily from $1 to $10 million. And continuous operation, it's still difficult to design. So, what's the playground on biomass valorization? Well, there's an increasing need to valorize biomass and residual streams. Just disposal, burning of the streams, that's not a sustainable solution. On the technology, the public domain knowledge is rather limited. It's highly IP protected, so there's not that much shared in the public domain. So that means you need hands-on experience for focusing on new developments and getting these done. And obviously, the second generation sugars is of increasing relevance. However, business cases are challenging. Well, I'm not going to discuss this slide into detail. This is an infographic on how we play as the BPF. You can read it in the presentation, which I will share afterwards. But I'm going to highlight some of the topics here. So first, what we as BPF, we do have an extensive experience with different biomass streams. So our facilities are outlined to validate processes at lab and pilot scale and make them commercial ready. And we think in a scale down approach. So once thinking about valorization of the biomass, we think an industrial scale concept and then translate it down to a proof of concept on pilot scale, and make it then, by executing at the pilot facility, make it ready for commercial scale production. We have a wide range of experience with different biomasses. Think of empty fruit bunches, all type of roots, coconut shells, hazelnut shells, different kind of agricultural residues, miscanthus grass, straw. So it's a rather diverse area of biomasses where we have been working with at our facility. So what's the challenge in biomass valorization? Well, what you see in the market, there are different variations being developed today. Some examples here, glycerol as a co-solvent for by leaf resources, different chemical solutions here, adding to biomass like the sulfonated lignin by Boracard. There are a couple of 1 or 2 stage development, pretreatment stages developed, and also just taking the biomass and filtrate or wash it before hydrolysis. Why are these technologies being developed? Well, it depends on what the focus is of the company. So you can separate out C5 and or C6 streams. You want to focus on the use of lignin, and in general, the processes are also developed with a lower severity, which also means a lower contaminants content, which can impact the application of the products you are focusing on. In general, it's kind of common sense. The higher the complexity, it also increases the capex and the opex of such a process. So at the BPF, we are using a 1 or 2 stage process. It's a continuous pretreatment with cold water wash and or steam explosion. And the reason we've chosen for this technology is that from product efficiency point of view, at the end, this process gives an appropriate structure disruption effect, meaning you open up your lignocellulose and you get your cellulose, hemicellulose, and lignin out of it. And it's also a simple way to get out of a pressurized reactor without too much dilution, which impacts also the cost price of the total system. Secondly, it's a process continuity. The technology we're using, it's originates from the pulp and paper industry, so it's already a proven technology, and that means that it's viable also on commercial scale. And you do have some flexibility in chemicals addition. In some cases, you want to add some chemicals like acid or caustic solutions to increase the yield of the pretreatment process. So basically, pretreatment technology, it's the foundation of a successful biorefinery. If you go from left from feedstock, you have different steps to get to the end product. Do some size reduction, chemical impregnation, pretreatment to get the sugars, to get the cellulose and hemicellulose. Then the hydrolysis, combining with the enzymatic cocktail to get to the sugars, and then concentrate the sugar solution. And it's important to realize that you can run as many pretreatment processes as you want, but you need to have a right enzyme cocktail in place for a good conversion of your cellulose into the sugars. And that's why we say here, pretreatment and hydrolysis, one is nothing without other. You need to combine the processes and optimize them to get a good sugar solution there. And also the pretreatment, so the valorization of your biomass, it's a balancing game. If you go for a higher severity of the process, on the pros, you get a higher yield for hydrolysis. The process is more robust. Otherwise, on the negative, the downside is for higher severity is that the filtration performance will decrease. You get more fine particles, which might lead to clogging of your filter, and the contaminants level will increase. And that can definitely impact the usage of your sugars for further processing. So it's a real balancing game, and it's different for each biomass. So you have for each the biomass, you have to design the process again. The next is we're talking about extraction or hydrolysis or taking the biomass and purify it. It's important to realize that the downstream processing also can make or break your business case. So how to get your product at the right purity in a scalable and economical viable way out of your stream. We do have an extensive track record here, and we definitely can help our clients out there to design an optimal process. And as a pilot plant, we have a wide variety of downstream processing equipment here, and where we can design the process and make it viable for extraction of the product. So in the presentation, I give you an example of a process which we ran a couple of years ago. We did an integrated demonstration study with the client, and it was really important to prove the process and to get some design and financial requirements for commercial plant investment. And we run this process in the 24/5 mode for about half a year. Please follow the link, and you can see a movie on the process, how we executed it, and how the process actually was set up. This is some examples of our pilot plant. This is the raw material handling, where we take the biomass and grind it to the right size. This is the steam explosion unit, where the biomass is pre-treated into release of cellulose and hemicellulose. This is a typical unit of a filter press, which is can be used for pressing out and for purification. And also a key part of the pre-treatment part is the enzymatic hydrolysis. We do have a couple of vessels here. Typically, they are run for a couple of days with different cocktails and to release the sugars. So why would you use a pilot plant? So if you consider to change the process conditions, or you want to have a feedstock and change the feedstock in an existing process, second option could be scale up of a new technology. However, you're only having lab facilities, or you don't have any factory, or you do not want to use the existing commercial factory for trying out this. And the solution is to go for pilot scale testing. It's less costly, less risky, and shorter time to market. Basically, you tap in experience which is already available at the pilot plant, and we can think along offering technical and economical viable solutions. So it's all about piloting, is all about de-risking, business cost savings, and shortening time to market. So in summary, the last slide of my presentation, if you look at biomass valorization, economy of scale, that's really, the entry barrier is high. However, the need for circular economy cannot be ignored. The technology is feasible, but a lot of details in scaling up need to be handled well. And the pretreatment process needs to be optimized for each feedstock, each enzyme technology and application. And that's where we can help you out. We can help to kickstart the biomass valorization. We have lots of hands-on extensive experience at the BPF, both on lab, pilot, and industrial scale. And de-risking of the business and shortening time to market. So I've run quickly through this presentation. I shared a copy of one. Please let me know if you have any questions afterwards by email or in this session. Thanks for your attention.
Thank you very much, Peter. Next presentation, I invite Professor Luuk van der Wielen, who's professor at the Technology University of Delft and director of Renal Institute from the University of Liverpool. Thank you very much for accepting the invitation. Luuk, the floor is yours.
I tried to unmute, but I never work with the Google platform, so sorry for this. And I also see that I have some difficulty of sharing the presentation. I do have it, obviously, but
about the permission.
let me.
Okay, now it's perfect.
It is now okay?
Yes.
Perfect. Well, thank you very much for having me. I came a bit late into the meeting because I was with one of our industry partners, and that is Irish Cement. I think a few years ago during the height of the collaborations with NIPE and Unicampi, I would never have dreamt that these are the sort of partners that we are working with, but we actually do at this moment. So I'll give you a little bit of the journey where we are, and I think it is representative for the Northwest European journey. Bio will be part of it, circular will be part of it, but we changed a little bit the orientation. I must have used this slide a few times. The industrial engine of the Northwestern economy is still very much industrial manufacturing of all sorts of goods, chemicals, materials, energy components, fuels, food and feed, and how important other sectors such as ICT and banking and so may be, still a big foundation under the economy are those. The issues there, so these are the issues obviously are, it doesn't only bring good economics, but it also brings emissions on one hand and resource scarcity on the other hand, and the geopolitical situation of today evidence that. I'm in Ireland at this moment, and if you zoom in on this graph, and I fleshed it out, is the GDP per capita. That is enormous in this part of the world if you compare it to other parts. But it is also firmly linked to the emission profile, the resource scarcity that we have. So we need transformation. Northwest Europe in general. Aggressive carbon emission reduction in construction and other materials, in food and transport and so on. And these are not wishes. These are at this moment even targets, or even further mandates have to be done. With such an enormous transformation, economic opportunities needs to be looked at as well. Diversification, creating new jobs, and how does all of this gets into in sync with the environment, including biodiversity. If we take a look into Ireland, I just take some pictures to characterize it. These combined are 95. These demonstrate sectors like construction, agriculture, all sorts of transport, including data transport, that are responsible for about 95% of the Irish emissions. So if we start looking at it, we should be looking at the future of these sectors, and probably combined. This is another diagram that I've used in the past a lot, in which my view on the world is sort of condensed into a triangle with carbon, hydrogen and oxygen on the corner, and most of the industrial chemicals and fuels can be positioned somewhere in this diagram. The fossil side of it is clearly mostly at the bottom of this diagram, which in a way is good when it concerns energy carriers, but is completely useless if we talk about packaging and construction materials. We don't need the high energy densities that go with that. But the way that we have built our economy is because of the abundant availability of fossil resources. That is clear. Others have discussed that as well. If you take a look at the sectors where that is going to, like construction materials, the biggest is concrete and cement. I just came from the cement plant, I told you, which are big carbon emitters. Fuels, both for mobility on the road, air and sea, and materials such as plastics. And in general, we did not even look at the emissions of the food sector. If you take a snapshot of the Dutch economy, this is what we call a Sankey diagram that shows the flows of material. Dutch economy is still driven by crude oil, and that's a big problem. Obviously, and that was a topic of the last 20 years of collaboration between the Netherlands, Delft University in particular, for what I can comment, and the Brazilian colleagues, certainly those at Unicampi and NIPE, was to look into where can biorenewables play a role in this greenification. And we worked on a lot of projects that looked into the possibility of finding drop-ins for plastics, for fuels, and so on. But what we still see is only partial solutions that come. And none of that really showed the solutions to the large-scale emission sector, such as construction and the agro-food sector. So that world is changing, and we need to take that into account. For Brazil, bio can be a much bigger impact in the totality of this, but not for Northwestern Europe with roughly 500 million inhabitants and a much smaller footprint, land footprint. Bio-based resources in this part of the world are really modest, and they don't compare to the massive materials flows that come with crude oil and gas. So the summary of what is available is, well, in the order of 50 million tons a year only. That is not even a fraction of the crude oil requirements. So there's a significant problem in resourcing, and we have to start looking at that. Going back to the Irish situation, you're probably not really familiar with the Irish history, but the state of Ireland started in the 1920s. And very early on, there was a significant project that took about 40% of the national budget and that transformed the Irish economy, and that was an hydro dam, the Anacrusha Hydro Dam. And actually, it is very close to the institute that I'm currently leading. And one of the runners, one of the turbines, you see that behind the group of people here, of which one of the guy with the gray suit is the director of the power company of Ireland. At that time, and we should not underestimate it, that plant alone transformed completely the Irish economy and made electricity available outside of places like Dublin. Today, we look at that in an entirely different way. The big resources that Ireland has and completely ignored for like 100 years are those related to wind. And if you see the enormous potential of Atlantic wind, the current estimates are like 80 gigawatt. We have to feed that into the solutions. So the development of the story is not that bio will be playing a bigger role, but that bio in a much larger framework has to play a certain role, and we have to identify. We are still very much at the beginning of this journey. The Netherlands is really a wind country, but we even don't have 10 gigawatt installed. So we are still really much smaller in terms of energy requirements than the fossil side of it has. So we have to be very careful on how we do things. And for instance, a country like Ireland is in a much better position for wind potential that probably will exceed massively the Irish domestic needs. So you remember the triangle with carbon, hydrogen, and oxygen in the corners, and we look at it currently in a slightly different way. So we look at it how renewable energy, and in the view of Northwestern Europe, that is mostly wind, renewable carbon, and that could be biogenic, bio-based carbon, or maybe in the future carbon from direct air capture, can help to enable these main economic pillars. And we do have strengths in some of these areas, and we are building strengths in the other areas. And the topics that should drive the economic development are put in the core of this. So the smart manufacturing side, we cannot do all of this by trial and error, and the pilot plants are important, as Peter just said a moment ago. But we are moving more and more to the digitization of the design process. Environment is not like the last thing that you'll be looking at, but it is guiding the principles. And circularity and process efficiency are all there. And the environment in totality is so dominating that you would just not get a permit anymore. The social license is everything. So now let me give you a little bit of an example, because there are many that we can think of emerging sectors that we did not have before, but where bio can come in. So, for instance, the 75 or 80 gigawatt of Atlantic wind, that will all be floating installations sea is just, the Atlantic Ocean is too deep for fence posting. And if we just take the current state of technology, turbines are generally like 2 megawatt. You would need around 37,500 turbines, which are really large machines. Each of them has blades of 25 tons each, and they have typically a blade has a lifetime of about 15 years. That would require close to 3 million tons of composite materials, which are today all plastic materials, and it is about a 90 billion euro turbine investment. With the 15 years, it will yield around 140,000 tons of blades to be recycled per year, with roughly a value of 4 or 5 euros per kilogram. So even in the recycling side of it, there's a business opportunity that is close to 750 million euros per year, and we are looking what that entails. At this moment, the thinking is that with this large scale of in a way, plastics use, you should be looking at other possibilities. For instance, lignin-based carbon fiber. My institute has been developing that with the mechanical strengths and specifications that are suitable for wind, as well as resins that would bind them together. That should be seen in combination with the more efficient, meaning larger turbines. So the next generation, which is currently being installed, are 5 megawatt turbines, but the generation that we expect from about 2030 are 20 megawatt type of turbines. Blades of close to 200 meters in size, so these are enormous machines. And this would be an area that doesn't exist. And if we start using today's technology, fossil-based plastics, we just are on the wrong direction. So at this moment, we are looking what the scale up entails. That would be a layer of efficiency. So the scaled up versions are all the blue numbers that you see in brackets behind the ones that I just mentioned. So you see significant cost reduction possible by that level of innovation. But we also believe that that bio needs to come in to help reduce further the carbon footprint of the machines themselves, which is an emerging large sector. It is not only Irish, but think about the whole northwest of Europe, in which a significant new industry will be coming. In the same way, and that is also an explanation of the title that was Bio to Energy and Energy to Bio, the issue of food production, in particular protein production, and the related carbon emissions is something we cannot ignore. For the Netherlands, it is about 20% cattle-related carbon emissions. For Ireland, it is about 40%. So if we want to significantly reduce the impacts, we need to look at alternatives. And the alternatives are alternative protein, fermentative protein. And we have a range of projects with partners that you would in the past never have seen on one place, such as RWE as a power company and DSM as today mostly a food company. But the combination of renewable energy on one side and renewable carbon on another side, and that carbon could come, for instance, from the cement industry or from bio. That doesn't really matter for this context. The process still is a biotech process as we foresee it. So gas fermentations with carbon dioxide that may come from a steel mill or in our case from a cement mill. And these are the serious developments that we see in this part of the world. We have strengths in those spaces. So some of the projects that we worked on also with colleagues at Unicamp was to look into also auxiliary materials, in this case for acidification, which could also be done by carbon dioxide, and how that would take away the cost of the classical chemicals in the protein manufacturing process. So we base it on things we know. We have a technology base in which we can contribute, but the setting is entirely different. So without going into the details of these diagrams, you see that my diagrams are changing in their form. We try to get to much more sector-oriented solutions, look at the combination of the sectors, move away from materials that came from the classical fossil industry to others, and try to come to a much more circular, that should be the next slide, and also the final one, a much more circular economy in which there is a role for green and bio-based, and there is a role for other renewable energy sources, and there is particularly a role for recycling in all the main sectors that are at this moment the emissions. So yes, significant transformation, yes, costly, but yes, an enormous opportunity as well. So with that, I would like to close and take all sorts of questions that you may be interested in. I have a short checklist for cases that work based on how the actual process implementation and intensification comes in. But let that be for another meeting. Thank you very much.
Thank you very much, Luuk. Now the last presenter, but not the least, I invite Sven Schaller. He's the executive support team of BPFZ. I will not pronounce the BPFZ. Thank you very much for accepting the invitation, Sven. The floor is yours.
Yeah, thank you, Bruna, for the invitation. I will also share my presentation right now. Yeah, so thank you very much for the invitation. As I said, I will give a brief introduction into the application of biogas systems, in particular in the Brazilian ethanol sector. What I've seen in the last couple of minutes is a very close connection to the presentation of Jens Bo and also from Peter, because we are talking about biomass potentials which are not used at the moment. First of all, I would like to introduce briefly DBFZ because it's a quite complicated German word, Deutsches Biomasse-Forschungszentrum, which is in English something like German Biomass Research Center. We belong officially to the Federal Republic of Germany, represented by the Federal Ministry of Food and Agriculture. And because biomass and bioenergy is a cross-sectoral topic, we have a supervisory board where some other federal ministries are in, like the Ministry of Education and Research, the Ministry of the Environment, the Ministry of Digitalization and Transport, the Ministry for Economic Affairs, and also the Saxon State Ministry for Energy, Climate Protection. What is particular in our construction is the International Research Advisory Council. You see it in the middle. They have a consultative function for DBFZ for the development of our research in the next 5 to 10 years. And we are very happy and very delighted that Arnaldo Walter, Professor Arnaldo Walter, is a member of this International Research Advisory Council. What we are doing is what you see here in this scheme. So we in general actually analyze different types of biomasses. You see in the upper part, so oil containing biomass, sugar containing biomass, starch containing biomass, etc. And then there are different biomass conversion pathways, like the biochemical conversion pathway, the physical chemical conversion, or the thermochemical conversion. And then you get a broad range of products, like solid fuels, for instance, pellets, bioethanol, biogas, biomethane, vegetable oil, biodiesel, etc. And what is unique with biomass is, and this is what you see below on the right-hand side, that you can convert biomass in mobility, that means in fuel. You can convert it into electric power and also into heat and cold. And this is a very something special and well, very precious, but also very costly, because if we talk about the energy system of the future, then it becomes clear that biomass is the most expensive energy carrier, but also the only one that can convert in different sectors. We focus therefore our research in those different processes. So we have one process that is focusing on the anaerobic digestion, mainly biogas. We have a department focusing on biorefinery research. We have the third department focusing on heating technologies, and all is combined with the catalytic emission control. So our aim is to have technologies without any greenhouse gas emissions. And you see in the lower part, we have also one department focusing on all systemic questions. So what is the potential of biomass? What is the life cycle assessment? They do scenario development. They do analysis of the combination of different types of renewables like solar, wind, and biomass. And what I will show you now are some pictures of our research institute. So we have a known research biogas plant. We have a combustion lab, full conditioning lab, and you see it here also small scale combustion furnaces, syngas applications, and so on. This was only to show you how we have cooperated with Brazil in the last couple of years. Unfortunately, I have to admit that since 7 years, we have not been able to run big projects due to the political financial situation, in particular in Brazil. However, I would like to present you some results who may also be valid even today and maybe even more relevant than 7 years ago. And the point is that Brazil has a lot of sugarcane. You all know there are roughly 400 sugarcane plants with the season. So from April to November in the center south, and in the northeast, it is from November to April. And we analyzed the energy potential of this of the residues of sugarcane in the state of Sao Paulo. Well, if we use 50% of the straw, then you see the potential for thermal energy for the state of Sao Paulo is roughly 16,000 gigawatt hours a year. For bagasse, it's 11,000 gigawatt hours a year. For filter cake, still 2,500 gigawatt hours, and for vinasse, 3,500 gigawatt hours a year. So the total thermal energy potential of the sugarcane residues for the state of Sao Paulo is more than 30,000 gigawatt hours a year. And if we talk about the electricity, then you see that the potential is 19,000 gigawatt hours a year with 50% of straw, 13,000 gigawatt hours if you use 25% of the bagasse, nearly 3,000 gigawatt hours using the filter cake, and 4,000 gigawatt hours using the vinasse. Makes a total of roughly 40,000 gigawatt hours a year for electricity. If you compare this electricity potential, then you see the gray column. So this is the whole electricity consumption of the state of Sao Paulo of nearly 39,000 gigawatt hours a year. And the potential of the residues of the sugarcane sector is nearly 40,000. So that means all electricity of the state of Sao Paulo could be covered with the biomass residues from the sugarcane sector. Now we have the global situation of the war in Ukraine, with Russia and Ukraine. And what is relevant in this respect is the replacement of natural gas. And we also analyzed what is the potential of the biomass or the sugarcane residues for biomethane production, also for the state of Sao Paulo. And if we use 50% of the straw, then we will have a biomethane yield of nearly 5 billion cubic meter a year. For bagasse, using only 25%, it will be 3 billion cubic meters a year. For filter cake, still 750 million cubic meters a year, and for vinasse, more than 1 billion cubic meters. So it's a total of roughly 10 billion cubic meter a year. And you see here in this slide, using those residues from the sugarcane sector, you will have a yield which is 50% more than the actual consumption of natural gas in the state of Sao Paulo. There's one crucial issue, and this is what we have discussed in the last couple of years, last couple of months with the University of Unicamp, that we should establish a process that is running during the entire year. So I've shown you the seasonality of vinasse and also of filter cake. And we developed in 2015 a concept that would make it possible that the filter cake during the off seasons goes through an acidification tank, and then you will have the solid liquid separation, and you can use it in a USB fermenter. And during the season, you can use vinasse as the feedstock for the USB. And then you see the scheme here, what we have developed, and which will further develop by Unicamp in the last couple of weeks and months, to have a season from April to mid-October, November, using the filter cake, and then you have the utilization of vinasse for the rest of the year. So you would have a biogas system which is running through the whole year. However, this scheme, and this was also topic in the presentation of the other partners, has not been implemented by the industrial partners in Brazil. So there was no necessity, prices were too low. But now with the changing conditions on the world market, and having in mind the conflict in Russia and Ukraine, maybe this will be an opportunity for saving not only greenhouse gas emissions, but also for saving costs for the Brazilian energy sector. This was very briefly the presentation that I wanted to show you, and I'm very open and I'm looking forward for your questions. Thank you very much.
Thank you very much, Sven. Now I will invite some professors from here at the camp to compose our roundtable to improve the discussion. So at first I will invite Professor José Maria Ferreira da Silveira Jardim. He's our associated coordinator of NIPE. So thank you very much for accepting the invitation. And Professor Luana Mattos, she's professor of the Faculty of Civil Engineering, Architecture, and Urbanism from here in the campus. Thank you very much. And finally, I will invite Professor Gustavo Mockaitis, he's professor of the Faculty of Agricultural Engineering. Thank you very much. So now I open for questions and comments for the speakers, for our invite. Before it, I will ask for the invites from here to briefly introduce yourselves. Then start.
Okay. Okay, my name is José Silveira. I'm an economist, agronomist too, and then I work at the Institute of Economics. And my main, I've been working with scientometrics related to energy and bioenergy research, but now we are trying to go a little bit further in some projects with the Center for Interdisciplinary Energy Research, to do some economic analysis performed to understand better this kind of very complex situation. And I think that all of the presentations that we have a lot of opportunities. I don't want to repeat what Jean-Marc possibly told in his presentation, but I think that he's right that I would say that the traditional economic analysis trying to understand what is profitable, what is not, and the relation with prices is no longer usable in case due to the complexity of the possibilities. We have seen that there are two types of effects. I think one is the variety, a lot of variety of options and technologies and energy possibilities. On the other side, all of them are competing with themselves. So you have a fierce competition, and then you have simultaneously a scenario that you hope that oil prices go up, but simultaneously you have the perspective that energy will be very cheap in the future. And that is a kind of puzzle that we have to solve in the next years. I think that each country needs to know how to manage their resources, and using their resources then try to figure out what are the priorities to get at.
Hi, my name is Luana, so I'm an associate professor in the School of Engineering and Architecture and Urban Design. I work with the wastewater treatment and over resource. So thank you for the invitation.
Okay, my name is Gustavo. I'm a professor of the Faculty of Future Engineering here at Energia. Currently, I work with two line of research. My classic research is in anaerobic digestion towards biogas and biomethane and also biohydrogen. And we're getting into biomass and residues pyrolysis now. We're starting this new research, in our lab. And I guess that's it. I'm a chemical engineer, but by formation, but I'm working at agriculture engineering. So things are kind of crazy there. Thank you very much for the invitation.
Okay, thank you. Now I open for questions. People from here, person, and people virtually. You can raise your hands. Well, but I think I will start with the question for all the speakers, I think. My question is about the integration of university and companies, or research center and companies. We could see here maybe the presentation of Peter, also the speech of Luuk, and who was in a meeting with a company. So how do you see the integration in your institutes, and how long it took to have this consolidated integration. Because here in Brazil, we are in the beginning of it. We are, at least here at the Unicamp, we are very, very interested into to make this integration strong. Of course, we have many challenges of doing this, and so that's why I want to listen to you to know your vision about it, about this important integration. When we try to find the actually to base it, to use the basic science to reach the technological solutions, intelligent technological solutions in the application. So who wanted to start? Maybe there's a, okay, I think it, Luuk, please.
Yeah, I'm happy to comment it. I think the sectors work so much in silos that we did not, at least in this institute and our partners, we did not yet manage to integrate to the levels that are necessary. I think we have just started to understand the general solution, and having worked in the bioeconomy space for most of my career, getting into this institute where bio is just a fraction of things that we do, and where we have a significant group that, for instance, works on wind energy, on power storage, electricity, battery research, and so on. People that work on things like carbon capture from a variety of industries. People that work on materials. This is Materials Research Institute. So we look at materials in a very general way and not from a particular perspective. So I would say that the journey only started, and what was already a concern a couple of years ago, that the transformations would be coming much faster than we would expect, that the resistances were high. But we see now that a couple of calamities, partially the geopolitical calamities, but also the climate side of it, are getting together. And we can't just wait for another 2-3 decades for things to resolve. So there's much more pressure on the system. I think that the next 10 years will show, hopefully, where things will work, but the urgency of getting a fuller picture are important. So being a chemical engineer myself, I really appreciate collaborations with economists, such as you also have in the institute, ecologists, and it is a collaborative effort. I mentioned that I just came from an industry partner, which is Irish Cement, which is sort of classical partner here in the institute. We have done cement-related research. But to see them as a source of carbon and potentially a food manufacturer, or at least feeding into food industry to gas fermentations and so on, that is a mind shift. You know, I'm not throwing out of the company because this was a proposition that was completely out of their landscape. But they need time to understand and see the opportunity and see how this gets integrated. So the technology isn't ready, the systems are not ready, and that puts, I think, a significant challenge where institutes like NIPE, which has done a lot of bio-based work in the past years, but originally had a much broader mandate also in other energy sectors, would be ideally positioned to help solve these challenges. So from that perspective, we at Bernal in Ireland and also my colleagues in Delft would really appreciate to continue this fruitful collaboration.
Thanks, Luuk. Sven, please.
Thank you, Puna, for this very important question. So due to the particular structure of DBSZ, what I have shown, we do applied science. That means right from the start, when DBSZ was founded in 2008, we were looking for business partners and working in cooperation with them. Actually, the situation is like this, that 50% of our turnover is third-party funding. That means projects together with business partners for the EU, for different German ministries. And 10% of our turnover is direct research for industry. So, and this may be a combination that could be interesting for Unicamp as well. So, having a group of business partners, in particular SMEs, maybe Unicamp could cooperate with, sharing the scientific results, having some smaller research projects together with them. And then the other part could be having the research, having the business partners in the research consortia. So, and that they put some money in. I think this would be helpful for bringing the scientific results quickly, and that is the point, quickly into practice.
Thank you, Sven. Yeah, it's very, very interesting to have a collaboration with the DBFZ, especially the biogas. We are talking about it. So I think in the next, very soon we have this collaboration, because for us it's very important to have this the integration of Unicamp and DBFZ. Professor Jens, please.
Yeah, it has been extremely inspiring also listening to your presentations. And you're right, Sven, there are a lot of synergies among us and expertise. If we sum up, I think it's quite much expertise already in the group gathered here. So integration and also quite much urgency that we should not only do research at our university, we really like projects and applied science jointly with the industrial platform in Denmark and Europe. So projects and case full-scale examples in the region of Sao Paulo, you really have one of the best places in the world for a biorefinery platform, and you have already fulfilled two of them, and together with DBFZ and us and the Dutch expertise and so on, and your own, we can make a fantastic maybe testing here and there in the labs, something partly, but also then designing and go for a full-scale biorefinery platform where the green gas is also part of it, because then you'll see it will open up so much more for you, not only for you, for us. It was just my comment.
Okay, thank you. Yes, we are working on to have you as a guest professor here at Unicamp. Let's get it. So, for comments, for questions from the audience. So, for Professor Jens, you talked about the Indicon, ethanol producer from Denmark, right? And I would like to know, where do you most use the bioethanol in Denmark? And if we have problems with finance, I think you produce more from sugar beets. Ethanol you produce from sugar beets, right? And I'd like to know if you have, how do you manage finance? Because here in Brazil, we have a big problem that we are trying to solve. The solution now we are putting in practice is the biogas production. We have maybe the biggest biogas plant here in Brazil with the Jardim. And so I would like to know, what do you do with the finance that you produce in Denmark? I know that it's much less than here in Brazil. Maybe we don't have a problem with it. But I'd like to know what's the destination of your vinasse? You are mute.
Yeah. Sorry. We're not really using vinasse at that stage, but the results from Sven, I can agree on that. We use byproducts from sugar beet manufacturing, and we're also going to construct 2 large biogas facilities, but we always do co-digestion. It's also why we are cooperating here. We really want to make co-digestion where you maybe also in the region we are going to plan and organize some of the animal production units so we can use some animal manure, some straw, a variety of products, because then we can be much more flexible also into the vinasse and into the filter cake and things like that. So it's going to be developed in the project we are starting on from this year.
Okay, thanks, Professor. We have here a question from Professor Luana. Okay.
So we have seen during the presentation that we have a lot of opportunities. For example, Sven showed us the biogas residuals from sugarcane and producing electricity and so on. So I would like you to comment, what are the main challenges that we can face here in Brazil to put that in practice? So I know you have comments about the financial research that was like a bit lacking during the past few years. So what are more challenges that we have to
face? Do you want to comment about it or?
Sorry, was this a question for me? I had some interferences. Could you please repeat the question?
You have commented that we have a lot of opportunities when using the biomass from sugarcane and production of electricity is one. So what are the main challenges that we can face here in Brazil to put that in practice?
Indeed, I see that the biggest challenge to develop new processes quickly, as I said before, because climate change is really running out of space. So we do not have time to make basic research. So we have to focus on getting results as quick as possible. Well, and for research you need money. So and that is the challenge. So I've been in contact with Puna during the last couple of months, and that the issue is there's a call between Brazil and the German DFG. And the issue is that there's a mismatch, because on the Brazilian side, it's applied science. And on the German side with DFG, it's basic research. So, and how can both sides come together to have a common project? So we proposed actually this idea with the sugarcane residues. The idea of Unicamp was to use corn instead of filter cake. However, it's a brilliant idea, but we cannot find funding on the German side for this project because it's too applied. So, and this is indeed the mismatch for funding from our side, for our contribution in those projects. Well, I have no solution.
Yeah, this has been a challenge because we are talking about the collaboration, and the problem is that here we need the applied science, the sugarcane sector, especially the biogas production. But in Germany, they are the leader in biogas. Actually, they know almost everything in biogas production. So the problem is how to integrate this to find the money. Actually, we have the ideas, we have the project to integrate it. I think if we start the basic science here in Brazil with the sugarcane vinasse, sugarcane filter cake, we can do this, and we could have the support of German of DBFC in the scaling up of the process. But the problem is how to find the money to do this. This has been the challenge now. So in this sense, Sven, you show the results of the work of Leandro Janke. I had the opportunity to know Leandro and his work, and he performed a great research on anaerobic digestion of bagasse and filter cake. It's a different configuration about how we have here in Brazil. We normally use it filter cake in CSTR reactors for digested with vinasse. In your process, we have an acidification tank. That's very, very interesting system. So, but the research was in bench scale, right? Did you perform some scaling up about it, or do you have a plan for scaling up this technology that you performed in bench scale?
I have to apologize for my colleagues, so I don't want to monopolize the conversation. Thank you, Bruna, for this question. Indeed, scaling up is the same process that we have talked about. Then you would need a business partner, a company, maybe you need funding, and then you can test this process on a bigger scale. And please allow me a last comment. What is possible maybe for starting again the cooperation between Brazil and Europe? Maybe we can look for PhD students who could do their PhD in Europe on one of the topic which could be relevant for Sao Paulo State or for Unicamp. This was also the process with Leandro. He did his PhD at DBFZ. Got his PhD title at, I think, University of Leipzig officially, and this is something what is maybe easier to get, so some scholarship, than to get funding for a bigger project.
Okay, and there is a call between German and Brazil. Brazil is from CAP. I can share for the students because there's an opportunity to have this internship abroad in German for PhD students and also for young research. So we can do this also.
That's very good.
Even me, I'm delighted to do this collaboration with German. Maybe I will spend some time in German. Okay, Peter and Jens had to leave. Thank you very much for your participation. If the audience has some questions for them, we can send afterwards. Okay, Luuk is raising your hand, please.
Yep, I was. I'm not sure that money is the problem. I never believed that money is a problem. I think there are always ways to resource the funding, but we need to work towards it. And I think what I tried to show in the presentation that I had was that the journey in Europe has changed. It is not the same bio-based journey that we had 10 or 20 years ago, where there was more alignment of what the developments at the Brazilian and the European and certainly the Dutch side. The opportunities are clearly there, and but you have to recognize them. An ethanol plant is as much an ethanol plant as it is a carbon dioxide facility with very pure carbon dioxide. And you just saw that circular carbon is a real issue, and whether that is from biogas, which is also 30-40% carbon dioxide, or from a cement mill, or from a steel mill, or from an ethanol plant, it's all the same. So if you start recognizing where the technologies could fit, but they need to be appropriate for the particular jurisdictions. It makes no sense to do sugarcane-related research in the Netherlands and in Europe, obviously. But utilization of carbon dioxide is useful everywhere. So I think we have to first get our act together and better understand where the real needs are in each of these jurisdictions, and from there distill useful programs. The activities that we could fund with the help of APESPI and Be Basic in the Dutch case came from a longer discussion, not from one workshop, but from a longer discussion of what was useful. And at that time, we had significant support of industries that were active in both jurisdictions. At this moment, we have the same discussion with players like Braskem, who are active at both places also. So along those lines, I believe that I really welcome this interaction, because I think it helps us to understand where things are moving to in each of these spaces. And I think we have maybe to get a few more in which we have identified better what drives the various jurisdictions at this moment, recognizing that the geopolitical situation of this moment, which we are not sure how it will be resolved in Europe, is a major disruption of which we have to think whether that will be lasting or not, and none of us know.
I would like to add. I was thinking about the question Luana just did, and we spent a lot of time looking for the problem to solve. What is the major challenge? And I really think that if we ask for 100 different researchers about which challenge is the best challenge, we will have 100 of different answers, because this is a very complex problem. And I really think that is the beauty of the data, because you have a lot of different kind of opportunities, because the problem is an opportunity, and we have a lot of different point of view in how to solve it. So I really think that that is a very good opportunity for this interdisciplinary research we have here. In the near past, not a few years ago, interdisciplinary will be a challenge during academia. We have each researcher has his lab and work in his lab, and only talk with other researchers when go in the congress or in the conference. And this is a huge step toward industry that have bigger and real problems, and industry just throw to us to how can we solve it? Not only industry but also the government. And okay, we have to make like the League of Justice. So each of us has his own powers, and we have to get together to find good solutions for complex issues. Like I said, I see beauty on it. This is a very good challenge and this is a common challenge, to get together and find the right answers for all these problems we have. Bioenergy now more than ever is a question of not only strategy but sovereignty. So we have to look towards that. And each country has to find these solutions. And this international cooperation to find those kind of solutions is perhaps the most important thing we do here in academia and the industry and the government. We have to work together for that. So this is a very good thing to work with. So thank you very much for your question.
I would like some words about the financial, the banks, the role of banks in this picture, because in the case of Brazil, I think that there's this particular case that we have the NDS, the Development Bank, have been leading all the financial support of energy transition. And now there is a lot of criticism on this because of some things that happened in the year past related to what they have done with the NPS and some situations of take turns in Brazil. And then Brazil has this habit to go to the other side quickly. So now we were going to convince the traditional banks or financial enterprise firms to finance the energy transition. It's not easy. That's one of the big questions. How they behave, how they manage with this huge span of opportunities, how they have the intelligence. I don't think they don't have intelligence to do this. That's the problem. Okay. The cost-benefit analysis is no longer enough to analyze this. The case, I think that Jean-François has mentioned the question of the risks too, not of the opportunities. We have a lot of opportunities, but how to reduce risks, particularly in bioenergy, because the risk is not caused by the technology and the bottlenecks of technology that are clear in the case of bioenergy. Is simultaneously the speed that the alternatives are reducing, like going alongside the learning curves and then create some challenges. And bioenergy is not going at the same speed. That's a difference. And the fact that we are producing oil. What state is good, but it's generating vested interest that jeopardize all of the initiatives in alternative energy. I saw yesterday a very interesting puzzle. It was related to the presentations of Cortez and then the discussion of the hydrogen yesterday, because at the same time they pay attention from the fact that you can solve a lot of local problems, and locality is important. How to generate a network of combination of different sources of energy, particularly residues and bioenergy. And the other side, we saw that there are some needs of scaling up and being international, as the case of hydrogen. So I think how to manage this and how to think about the financial system, particularly behave on this kind of puzzle. Okay, I think that the policy metrics will be the challenge in the next years, and I think that Bruna has the idea of some eco parks, or yes, this agro-industrial eco parks that focus on biorefineries. That's the idea of integration, local integration. And then we saw yesterday that idea to repeat in case, the problem is that ethanol is not a commodity. No, hydrogen is not a commodity yet. So we saw the different things that will be the challenge, mostly for the intelligence to think all of these things together.
Thank you. I think the integration is the key. and I'm delighted with the idea of agro-industrial eco-parks. Before Rafael, we have a question. We have the Sven with raise the hand. Please, Sven.
Yeah, please allow me a very short comment, because what you have said, you both, is very valuable. So the question was, what is the challenge? And the challenge from my point of view is not science. We do not face any scientific challenges, but we face political challenges. And from my point of view, the most crucial political challenge is to integrate external costs. As far as we can produce with fossil fuels very cheaply, we do not have any chance with the renewables. So the point is regulation, political regulation, change the framework conditions for the renewables. That means that all costs should be covered for the fossil fuel based industries, and then we would get actually a way for finance the investment, because all have to cover the real costs, and that is from my point of view. We do not talk about scientific issues. Indeed, from my point of view, it's really political question.
Yeah, we talked about it in yesterday during the whole week, and it seems that we know the problem, but we don't know how to solve it, how to put the political part together with all about we know about the technology. We have a question from here, and after this we go to Luuk.
Professor Energia, you said ethanol is not a commodity. You're trading CBU related to ethanol, but all the biofuel on the stock markets. So what's changing?
No, there was a hope that you have an international market for it.
Okay, so
All of the initiatives on Africa, for example, they didn't find any markets for ethanol in Africa. That's what the market was the challenge more than and then it's my point. But at sometimes secretarially they said that it's important to be a commodity. That's the case. And now, yesterday, I think that Cortés was the most provocative guy here. So I think that people that always pay attention to the dates, see the last day presentation, that you can combine both. That very.
Luuk, please.
Yeah, mute. I listened to what Sven Schaller said about. Well, my word for it would be level playing field, but I think we mean the exact same thing, which is true. You know, at this moment we look into subsidies for renewable energy, but the subsidies for fossil energy are still 10 times larger, at least. You know, and so there is not a level playing field at all. And the actual costs of carbon emissions are not factored in. And you're right, until that moment that we don't have to pay any carbon tax on the meat that we eat, on the fuel that we burn, maybe there is getting something in, but not at the moment we put it in an aircraft. You know, so there is a very unlevel playing field for any of this. I think this is one problem that needs to be solved. Maybe carbon tax could be a solution to it. So there are some ideas of how to do it, and Europe is working towards an across industry carbon taxation. The other point is the system's complexity. I try to point at the three main emitting sectors in my view. I try to simplify the discussion and I know that is oversimplified. We have transport of people, data, goods. And to store them, that is the houses. So that is one big direct energy use and carbon emission source, others agro-food, and the other one is materials and the circularity. That's about 95% of carbon emissions in practically any country. The ministries that you are dealing with are all over the place. So this morning we had a call in Ireland, just before my visit at Irish Cement. We had a call with the aviation authorities. There are at least 4 not aligned initiatives that all deal with the aviation sector, all trying to green aviation. You know, the finance people look at it from the tax point of view, the transport people from the emission point of view, the energy people from the energy point of view, and the agro people have no idea, but they feel that they must be part of the show also. You know, and they come with all parallel things. So the system's complexity can only is not helped by this. An overarching policy framework, and I think that is where the academics I think there's mostly academics around the table, that is where we should be helping to get a grip on the system's complexity. And that is not by providing more detail, but by providing oversight, main contributors, and so on. So I think that is where we can help any of these places predominantly. I think that research is not that expensive. And there's always a good argument for if somebody says, if you think that knowledge is expensive, try ignorance.
Yeah. Yeah. In Brazil, we said that. Yeah.
No,
But I said this in Brazil.
this is no comment.
That's ignore us. But do you know Luuk who said that? This is no con, and I really think that something very famous said that for the first time. But
I'm pretty sure that I stole it from somebody.
But this is a good stealing. So
Well, changing the subject about the hydrogen and the electric cars. Yesterday we had a wonderful presentation from Mr. Pablo DC, the executive chairman of the Volkswagen Latin America. Because here in Brazil, it's not the same scenario of Europe. It seems that there is no sense of Brazil having electric cars because it's very, very expensive. And also we don't have infrastructure to do this. And we have the ethanol, the bioethanol. So there's no sense we just forget bioethanol and change the whole chain to electric cars. So the presentation of the Pablo DC was that his idea and in collaboration with Professor Gonçalo from here from Unicamp, we will research about the using ethanol to feed the cars and reforming ethanol to produce hydrogen. And so we have a car that is fueled with the ethanol and the autonomy is with hydrogen. So this is a great idea in the Brazilian case. And it's completely different scenario from Europe because if we don't have ethanol, you don't have ethanol like we have here. And so that's maybe it's a common sense that the electric cars in Europe is a good idea. So I just would like to know your vision about this mobility in Europe. I don't know who wants to start.
I'm happy to say something about this, but it goes. There's a wide range of topics that you address. I'm not convinced that electrical is not a good thing for the state of São Paulo. I'm not convinced at all. I think if you look at the mortality rates in the city of the greater city of São Paulo as related to particle emissions by combustion engines, I think you would serve public health a lot by taking the cars out of the combustion cars out of the city and replace them by electrical. So hydrogen may play a role in this, but I believe that electrification would be a good possibility, and that would point in a completely different view on ethanol sector or the use of biomass for this purpose. I think we haven't really thought through all these different options, and what occurred to me now, being 7 years in a not specifically bio-based environment, but an environment in which other places, we are often very much locked in by the area where you're from. I remember that many of the solutions that I thought to have in the past always started with bio. I never thought about anything else. And I think if we try to take a broader perspective, Brazil has a lot of land. Solar would be an equally good option as well. There's a lot of wind also on the southern part of Brazil. I was once in Rio Grande, and I was blown away on the beach. So there is a lot of wind in that region as well, and that could be part of electrification also. So I think we need to do a little bit more system study, but using the agro footprint of Brazil, and particularly for things that need stuff. And to me, materials and food is stuff, and energy is not necessarily always stuff. Not always material. So I think we should distinguish between those uses and prioritize what needs really material, like food, like materials, and prioritize agricultural residues for those. But of course, there are remainders that could go into energy use. But the eye was open to me on the scale of wind and solar that can be harvested if we want to.
From my side, only very brief comment also. We think that biomass should be for niches like Chat A1, for instance. The rest should be electrical. So we are not even convinced if hydrogen is the best solution, because you have to produce it somewhere, then you have to convert it with a lot of losses. You have to import it into Europe. So, however, the electrical solution, what is proposed, is indeed the best for the car sector, from our point of view, and biomass should be used for some niches where it's really complicated to get or to find an alternative like Chat A1.
I think you have to unmute, Bruna. We can't hear you.
Okay. Professor Thelma, please.
Hi, everybody. Thank you very much for this workshop and I'm listening. Very interesting speech. I would like to ask Sven, when you say about electricity is best, which electricity coming from which feedstock, please?
Renewable, so solar, wind.
Only solar, wind, but there isn't enough, Sven, in the world.
We do not have enough biomass neither, so.
No, but no, because you just mentioned that biomass is not a good option for our country. It is. We have plenty. We have much more than necessary. So I just wonder what you meant.
Actually, I've talked about the European vision.
Okay, I'm sorry then. I'm sorry. Okay, thank you.
Thank you, Thelma. Okay, now I have maybe a polemic question. We have seen, actually, we have been giving the energy transition. We saw this during all the presentations here at NIPEWeek. We have a great discussions on biofuels, hydrogen, electric cars, decarbonization of the petroleum industry. But the conclusion is that the world is very, very dependent on fossil fuel. Maybe Brazil is in a privileged position. It's a different position from the rest of the world. But especially now with the war, the Ukrainian war, the Russia war, we see that Europe is very dependent on the natural gas from Russia. The specific case of German, sorry, Sven, it catches my attention because German is the leader in biogas production. I don't know in the case of biomethane. I know Sweden is very good in the biomethane production. I don't know if German is as well. But we are the leader in biogas production, and the paradox is that we're very dependent on the natural gas of Russia. So we have a big problem now. So what do you think about it? Where German performed some error, or maybe what was the fault? It's a very, very complicated case because, as I said, I think Luuk said also, it's very difficult to compete with the price of the fossil. But at the same time, Germany is working a lot in the renewables. And even though it's very, very dependent, I think if maybe, I don't know if I'm correct, but I think if 50% of the natural gas came from Russia. So, Sven.
Yeah, the question is really relevant and indeed is discussed at the political level in those days. So what can be done? So I think that the biogas sector in Germany with those 9,000 biogas plants could replace some 30% or 40% of the Russian imports. However, this is not the answer to your question. We need the Energiewende, the transformation of the energy system that started in Germany some 20 years ago. We need a renew start of this Energiewende. We need an urgent defossilization of our industry. And this is the answer to your question. It's not how much biogas can be replaced from Russia or Qatar, which is discussed at the moment. The point is to think in the midterm, in particular regarding the climate change. So we have to renew our complete energy system quickly.
I don't know how is the scenario in Ireland. I don't know if you use the natural gas from Russia. Look, if you are having, Ireland is having a problem with it.
Yeah, well, I think it is exactly as Sven said. If we only look at the specific opportunity that, for instance, biogas just would provide at this moment, we are not making the right choices. We should be looking at the end game, or whatever is the end game. Look ahead of the 2050s system. You know, the majority of gas. At least in the Dutch system, goes into the households also. There's households and there's industrial use. I'm not quite sure what the percentages is, but the households are there. And why is it going into the households? Because we still have a portfolio of homes that are not even at a B level of insulation. You know, so that needs to happen first, and then the remaining energy requirements should be taken in another way. So we have to start thinking about the full redesign of that system. And that is why I said it is a systems thing. Politicians who drive the ministries are thinking 4-year terms. This is a 40-year development before we can even afford this. It goes with the replacement of the fleet, which is roughly 10 years, with the replacement of the aircraft fleet, which is 40 years in general. So these are really longer term trajectories. If we jump on a single solution now, we may be on the wrong one. What would be good is if we have like a national roadmap. That was a discussion I had this morning with the ministries in Dublin to get to an aviation roadmap. You know, it is not whether SAF is part of the show and where hydrogen comes in, but how would you look at that in the next foreseeable future, including where the hydrogen agenda would bring us in relation to the material sector, to the agri-food sector, and so on, because there are these competing uses. And we have to produce a number of roadmaps that include all of that. If we think it is a simple fix, we won't get the right answers. If we only look at the transitional solution, we don't get the right answer. So it is really a matter of looking at the system's complexity. This morning we just discussed scenarios of basically a very simple sort. Are you solving your own problems only, or are you a player at the global level? Ireland nor the Netherlands can afford to solve their own problems only, even if they can. They cannot. They should be interacting with the rest as well. And the other one is how close to today's technology do you want to operate, or how forward-looking are you for innovation? Can we feed with the current animal husbandry? Can we feed the population worldwide, or do we have to go to alternative proteins? If that becomes part of the discussion in combination with transport, in combination with materials, then we can start having meaningful discussions on, you know, where should you be using the biogas opportunity in that part of the world for, and how would you go about with the wind opportunity in Ireland? There's much to be said about it, but it is a systems solution that we must be looking into.
Yeah, and I think if each country has different solutions, but to reach the same objective, if the objective is the decarbonization, we can do this from different ways, depending on the situation of each country. But yeah.
Ben's speech just remind me another slogan about our dependency of fossil fuels. And I don't remember who said that, but regarding this dependency, is the Stone Age didn't end because the lack of rocks. So we have to get rid of fossil fuels, not because we're lacking of fossil fuels, but because we need good alternatives and sustainable alternatives for it. So this is no con. I don't know, as Luuk, I don't remember who said that. It wasn't me. I'm just repeating it. But this is a good saying.
Yeah, the Stone Age remark was also from a famous person.
But and finally, I think that the food security is becoming a problem again. We thought that with the biotechnology and the green revolution, we have solved this, but now it's becoming a serious problem, because not because you don't have food, but because food protein, for example, is concentrated on America, and then now is becoming a real problem, close to energy problem.
And stopping to bomb the Ukraine helps also a lot in improving the food situation.
Yeah.
Yeah.
Stupid things.
Yeah. So we intercede. Yeah. And look, you were talking about processing the intensification using biomass. Do you have some examples? I mean, are you using residual biomass for doing it, for producing biomaterials? And I'd like to know if you have some examples in Ireland of the where you work, which residual biomass you are using for doing it.
Yeah, well, we don't have really a biomass processing industry in the way that we discussed here. Of course, there's a big agro food sector with classical products, but we do have forestry, which is very much geared to construction materials, so particle boards and timber. You would be amazed how much sawdust is created in a mill and how much tops and leaves you have from a forestry sector. Less than half of the harvested tree gets into a final product. So there is a lot of material around, and we started to interact with the larger players in Ireland. For instance, one is Quiltje. It's like a sort of state-owned forestry company. And there we got into the discussion of high-end products from wood. And for instance, lignin to carbon fiber is one of my pet topics. There we can have really top-end products with technology that now allows them to get at the specifications that are good enough for wind turbines, not yet for aircraft, but for wind turbines and anything that has lower specifications like automotive sector and so on. So we are looking for materials in that way, which is, I would say, like the first step into things. But I gave you in my presentation the example of looking into, for instance, the wind sector and the circularity of the end of life turbine blades. You know, this sector doesn't exist, but we believe that wind will be big. So you have to now start looking into how would you get to your materials resources for that future wind sector, and also how to decompose after the end of their life. So the design challenge that we are for is not only can we make carbon fiber, yes we can, but how can we get that into a mode of circularity? How do we get it cost affordable? And how can we link these two sectors which don't do much together? And working on that, you see that we haven't reached the end of the knowledge, because the same lignin turned out to be really good electrode material for batteries, for power storage systems. So all of a sudden, we are working on batteries with renewable electrodes, for which people are now looking into relatively inefficient storage, but the material is much more recyclable. So for home storage, you don't need a small and light battery. You can have a rather big and sturdy one, as long as it is recyclable end of life and made from materials that you can get easily. So the design specifications change relative to other uses that we didn't have before. So again, if we didn't have the eye on the future, on the impact of electrical, we would have not moved into this journey.
Thanks, Luuk. It's great to hear about it, because here at Unicamp, we are trying to perform the living labs. So we want to use the university to be a showcase for the society. And in the case of residues, here at Unicamp, we are not so good, because our residues goes to the landfills, and the food waste goes to the landfills, and the wood waste,
I just used this board a few weeks ago to write my project.
Okay, it's lignocellulose residues from the university. Yeah.
I will try Google Translate.
No,
because I don't remember.
The idea is to build a living lab using the residues from the university, because we can be a great showcase on it. So we can use food waste. I think it is
Pruning tree. Pruning.
pruning
Tree residue.
running tree residues. Okay, that's the word. So regarding the food waste, we have idea. I have some projects, PDG projects for producing biogas from the food waste. That is actually is very simple. I mean, German do this, Sven know about it, but we don't have the practical here at the university. So the idea that some projects that we have here is to produce biogas from food waste, but we don't have a project about using the lignocellulose residue. Maybe Gustavo has some idea about doing the pyrolysis. I know that we have a new renewable plant of the pyrolysis, but we don't have a project, a ready project on doing it. So that's great to listen that maybe we can do some collaboration on producing the biomaterials from the residues from here at the Intensification, and building a little lab, innovative little lab with intelligent technological solutions on how to manage all the residues from the university. That would be a great idea.
About using better the residues we produce here at the university. Well, first of all, shame on us, because we really have to do that, and we have to be an example for the rest of the country. So if we don't do that here, so
yeah,
I know we're missing something here. Of course, I hear it. This pyrolysis plants from Professor Cortez. We're trying to restart it. I have two companies, two environmental companies here at the São Paulo State that will financing the restarting. And I just submitted the project to Professor, so good luck to me to have people to work on it. And the main idea is to process not only pruning residues, but also urban residues that might include our residues here at the university, which is more stable than if you look towards the rest of the city. So I really think that if we can start doing good here and using this to produce a good science that could be scaled up for the cities, that will be a good start. So university should be sustainable. First of all, you're right to say that, and our plan is we'll try to help to improve the sustainability of this place.
Okay, we extrapolated a little bit the time, so does anyone want to make a last question, or can we finish the section? Okay, I would like to thank you very much, Luuk and Sven, that you just stayed with us in the round table. It was very, very productive. You are very, very invited to be here with us in Brazil. I know Luuk know so much Brazil, NIPE, and Sven, you are very, very invited to be here also. I would like to thank also our guests here, Professor José, Gustavo, and Luana. Thank you very much. And I hope to see each other very soon. Thank you very much.
Thank you also for having us. I enjoyed it tremendously, and yes, hope to be in person soon. Remembering that also digital contact costs energy.
Yeah.
No, thank you also from my side, Bruna, for the invitation. I'm really thankful for this discussion because there are always some new insights into the whole aspect, and I wish you good luck for you and the university to have some progress with your projects, with your ideas, and hopefully we can work together in the next couple of years. Thank you.
Okay, your collaboration is very, very welcome for doing this. Thank you very much. And in the afternoon, just to remember, we will have the presentation of the Center of Plastic Culture Engineering, coordinated by Professor Thelma. And the presentation will be Portuguese, but everybody's well invited to share with us the section in the afternoon. Thank you very much. See you in the afternoon.